Welcome everybody to another BAKERview brought to you by BAKERpedia, KPM Analytics, and Vantage Foods. And so I want to get into a little bit, first of all, here, where this seminar is all about donut production. Okay. And going to tell you a little bit about KPM Analytics. I'm your host, Mark Florka, by the way, in case you've never heard of me. That may happen. Sorry, I'm in a goofy mood today. Anyway, KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients, analyze products during the baking process, and ensure final product quality. Their comprehensive range of analyzers are used by food producers throughout their production to improve efficiency, ensure quality, and protect their brand. KPM Analytics is backed by 100 plus years of experience developing advanced products and processes for quality assurance and process control in baked goods manufacturing. Also, our sponsor for this BAKERview is Vantage Food. Vantage Food is a market leader offering customized solutions, in-house research and development, and an extensive portfolio of food processing ingredients. Their offerings include release agents, emulsifiers, stabilizers, processing aids, shortenings, esters, polysorbates, antifoam, specialty ingredients, spraying equipment, and much more. Vantage offers a full line of clean label solutions, including allergen-free, non-GMO, organic, kosher, and halal. And our guests today we are joined by Andrew McGee of KPM. Andrew has over 30 years of experience in the baking industry. He has a Bachelor of Business from the University of Technology in Sydney, Australia, and joined the bakery industry in Australia in 1987. When Andrew arrived in the US, he joined Northeast Foods in Baltimore, working for the Patarakis family in the bakeries, supplying McDonald's restaurants. Andrew then worked for iPro System Inspection Systems for bakery products for 10 years, heading up the North American operations before joining Schaefer Mixers, part of the Bundy Group. In 2017, where he now heads up the sales team, Andrew has rejoined iPro System, which is now part of the KPM Analytics Group, which includes such iconic bakery equipment brands such as Chopin, SensorTech, Process Sensors, Sightline, and Unity. And along with Andrew, we have Lena Boschbiane. And Lena has an education in engineering and in food science and specialized in cereal industry. She works for Chopin Technologies as part of the KPM Analytics since 2014. For more than 9 years, she occupied different positions and now manages the food products and applications team, whose role consists in ensuring the application development and the promotion of Chopin products. They provide personalized solutions to customers willing to improve control of their products and processes. Lena's responsibilities also include the standardization development closely associations such as ISO, AACC, and ICC.
So today we just want to talk about, obviously, one of my favorite subjects, actually, donuts. Taste wonderful, not exactly good for you if you eat them to excess, which of course I'm guilty of, but I love to talk about it. So first of all, we want to talk about some tools that can help to manage quality. Lena's going to talk about some other technologies, but I'm going to focus in on the vision side of the business. So let me share some slides here, and we'll go from there. So I always like to start at the end when talking about quality and inspection systems, because at the end of the day, we need to understand what you are trying to deliver to your customers. What are the key attributes? What are the things you're trying to monitor and maintain? And what parts of the process really are a challenge? So for donuts, obviously there's taste and texture, appearance, shape. Does the donut have a hole if it's a donut with a hole? On some products, you're going to have customized shapes. Is that shape correct? Is it right? And you might want to get some physical dimensions to make sure that the product can fit into the packaging or fit on your shelves. So length and width, and then we can also measure the height and volume of the product. So it can be very helpful. And of course, where you're putting toppings or icing on the product, you want to be able to see, okay, is the powdered sugar in place? Are the sprinkles in place? Is the icing in place? Is it properly covering the surface? So that's the sort of things that we can help you with using inspection systems. So right now, as far as quality assurance goes, a lot of you are probably just taking samples from the line periodically, every 30 minutes, every hour. You take maybe 12 samples from the line, and you'll be analyzing. You might be weighing them. You might be using a caliper. You might be grinding them up, getting a moisture analysis or a fat analysis. You might be doing a sensory test, scoring the product based on texture and appearance. But a lot of that is very manual. And again, depending on the throughput of the line, there could be thousands of products coming off the line per hour, and you're sampling maybe 12 every 30 minutes. So, 24 donuts every hour. You might be doing more than that, or you might even be doing less than that. So the challenge for people in the bakeries is, and this is the challenge we always had, was, okay, does my sampling process truly represent the variation on the line? Is it truly representing what I'm sending to the customer? And it's always a challenge. And obviously smaller sample size make it even more challenging. So what we can help you with is, there is one tool that we have is using inspection systems. So inspection systems can help using a color camera and also a 3D camera. We can do online inspection, and we can also do give you real statistics about 100% of the production. So that's a very powerful tool. One of the interim steps can be going to a standalone system. So this can actually replace the manual measurement station that we showed earlier. You can actually use this system, and it can be moved anywhere in the line, or it can be in a fixed position on the line. And you can take your 12 donuts every half hour, and you can run them through the system. This is a conveyorized system. So you can run it through, you can weigh it on the scale, you can run it through the system. And again, using a color camera and a 3D camera, the system can measure the shape, the dimensions, the color. If there's toppings on it, can measure the toppings on it. And what it's doing is recording the data on the computer in this system, and that data becomes generated into a report, and then it can become available for analysis. You can go into a database. So over a whole day, you can, number one, start to evaluate your samples more quickly, because you're just putting them on the conveyor and capturing the data. And secondly, you can look at that whole data in very easily without having to key in data, summarize sheets. It's already there for you, and you can get trend graphs, you can get images, you can do a whole lot of information. There can also be an NIR sensor on this machine as well that can measure fat and moisture, if that's what you're looking to do. But the important thing is that the weight, the NIR data can all be incorporated into the database for the system. This is a video which I would encourage you that, I won't play this to you because it goes on for a little while, but this is just showing you how the system would be used. In this particular case, they're using it on biscuits, cookies, but it can also be used for donuts. And it just shows you how you would put the product through the system, and then the data that's shown and the trend graphs that are shown. So after the seminar, if you get access to the presentation, you'll be able to look at that video. So here are a couple of examples of online inspection systems. So you can see here on a production line, this is the inspection system right here. And this is another system. And this one here is built to sanitary design. You can see the slope cabinets and things like that. But so every product that's going through this system is actually being inspected by the color and the 3D cameras. And there actually is a rejection mechanism on this system as well, so that you can see that you can actually reject any products that don't meet the specification. And this is a little video that will show you that system in operation. So you can see 100% inspection, 3D color camera and a color camera, and then the rejection mechanism. So you can see the product going in there now. You can see the laser line. That's measuring the height of the product and giving you a very detailed 3D profile. Just ahead of that rejection mechanism there, you have a color camera and a lighting system. as the products are tumbling down, there's an air nozzle rejection mechanism. So if the system sees a product that is not meeting the specification or the tolerances that you've set in the system, it will then reject the product and it will come across on a transverse reject conveyor over here. And you can actually see the rejected product. And also, images are also saved of the rejected products. And if you click on that image, you can actually see the measurements for that particular product, and the reason it was rejected would be highlighted in red. So typically the problem for vision systems is the boss is coming through the bakery, they see this product being rejected and they pick it up and go, well, why has this been rejected? It looks okay. But by looking at the image on the system, opening up the image, you'll see in red, oh, that one was too big by 3 millimeters, or that was too small, or some other defect. But again, it's quite clear. And then they will look at it and go, oh, okay, yeah, okay, I can see that. Yep, we don't want to have that product out in the marketplace, no problem. This is just giving you a little bit of a explanation of the technology that we're using. And we talked about the color camera. So there's a high resolution color camera, just one for the whole line. And what it's doing is grabbing an image of all the lines, so the conveyor and the products. And then this computer system is extracting the product away from the background, being the conveyor, and measuring each individual product. We then have the 3D profile camera that's working with a laser line that you saw here, and you can see here on this biscuit line, the cookie line. And again, that laser line travels over each product, and the system grabs a very detailed 3D profile, which is here is a profile of a donut. Here you can see quite clearly that the product is a little bit sloped. You can see where the hole is. So it's a very, very useful way of measuring the height. And then we also have systems where we have a gap between the inspection conveyors, and you can actually look from below and actually see the bottom of the product. And I'm sure you guys have experienced it as well, that oftentimes there is something in the bottom of the product. I know in buns, in my experience with McDonald's, something gets into the bottom of the pan, gets baked into the bottom of the pan, and oh, there it is on the bottom. It's a crumb, it's a piece of carbon, it's a sesame seed, a burnt sesame seed. So again, having the bottom inspection allows you to see the bottom of the product as well as the top of the product. Because I know online, the online inspectors that you probably have now, people don't always look at the bottom of every product, but this allows you to look at the bottom of every product. So it's, again, a very powerful tool. Of course, the camera and the light are below, and often a lot of dirt falls down. So we have to make sure that we keep that optical window clean. So once a shift, the optical window for the camera needs to be cleaned, as does the lighting system, just a wipe across to keep it clean. Okay, there are a lot of steps in your production process, and I probably haven't captured them all. And some different processes, different products have different processes. But okay, you're mixing the ingredients, you're sheeting or molding and cutting the dough, die cutting the dough for the dough pieces. You're proofing the product, frying it, cooling, and glazing, and freezing and packaging. Now, anywhere in this process, there can be issues. Leonard's going to talk about ingredients and mixing of ingredients. With vision, I can't really help you with that, but Lana can, no problem at all. From here on in, we can provide some tools that can be of help, and let me talk further about that. So what we have here is using vision for vision process control. So the video that I showed you earlier of the online system, typically that's installed after the cooler, before packaging. So the very last point. So if anything goes wrong anywhere in the process, the vision system can see that, and it can say, okay, this product is no good. I don't want to send it to the customer. Let me reject it off the line. All the rest of the products would go through and be packaged. And then you would have, as I said before, detailed data on all those products. You would have, average diameter, average height, bake color, and that information is shown in real time on a trend graph and Pareto analysis on the display, but it's also saved to a database, and reports are generated after the production run, or you can do a query on that database. But what we're talking about now is before that end of the line, and you can actually look at the different production steps. So here we have, forming. So we can do an inspection after forming, and we can alert if there is a problem. So for example, if I'm sheeting the dough and the dough's too thin or too thick, the system could, using a 3D system, we could see that, and we could set an alert to say, hey, operator, please come and look. We think there is an issue here. Or if the sheet's not evenly sheeted, one side the roller's not properly adjusted, so on one side it's a bit thin, on the other side it's a bit thick. So again, we can detect and alert, but we also have the functionality now to be able to also feed back to the forming process. So on the sheeting rollers, for example, we could see that there's a problem, and we can send a signal back to automatically adjust the sheeting roller. And again, when we get to baking or frying, we can do the same thing as well. Adjust bake temperatures or the time that the product's in the oven. So again, we can detect the problem and alert the operator, and we can also have this module where we're able to feed back to the actual process itself. And we really see that as the future for a lot of facilities, because what they're looking for is to have a closed loop where changes are detected at the problems are detected at the earliest possible opportunity, and corrective action is taken. Unfortunately, I've worked in the bread industry where, proof times and bake times, it can be, 2 or 3 hours before you or even longer, 4 hours before you see the final product. And it's too late then. I already have 4 hours worth of production that now I could have some issues with. In this case, at each stage of the process, you have a pretty simple vision control system that can then at least alert you of a problem, but then perhaps automatically correct it. And then, of course, you have cooling and freezing, which is the system that we would have seen here, where we are looking at the product just before it goes to packaging. I'm going to talk about a couple of specific areas here. So this is one of our systems, and this is actually on a biscuit line where we're using vision process control to do an oven feedback loop. So again, we're measuring all the products as they come out of the oven. We're comparing that against our targets and our ranges of acceptability for bake color. And then the system is using some sophisticated AI algorithms to then understand what changes need to be made to the process, either set points on temperature, venting, air circulation, venting, or time of bake, and ultimately feeding that back to the oven to make the changes.
And obviously, same thing could be applied to a fryer and stuff. Just that
exactly, to talk specifically.
Fryers tend to take just a little bit longer to equilibrate and stuff. So it's often done based on fry time. Yeah.
And that's a good point too, Mark, because you're right. It takes a longer to adjust. And even in an oven, it takes a longer to adjust. And what we've found when I first did this when I worked in the bakeries was that the system kept on pecking, so we made a change. Oh, it's too dark now. Oh, make it lighter. Oh, and it kept on going like that. So that's the real power of the sophisticated algorithms, is that you will see that even though the color is getting a little bit out of where you want it to be, on the donuts coming out of the fryer, you can actually, sometimes the system will hold, and you'll see that it's automatically adjusting, or it's not adjusting, it's just holding, because it knows that there's a bit of a cycle here, that towards the end of a batch, it's going to have it's going to have a change in the process. But other times you'll see that it will make a change, and it may take a little while that to flow through. But the advantage of this system is because it is seeing 100% of the product, it makes a change, and then it sees the result of that change, and it can learn from that change. So again,
it's artificial intelligence applied to quality control, and in that it's learning from the data that it assembles.
Correct, exactly. And I made that change, and it didn't make enough change. I need to make another change. And the good thing is it stores all this information by product for future reference.
So you can always review it. Yeah,
exactly. And then, of course, one of the processes when you're sheeting the dough, again, we can have a 3D system right here that's measuring, okay, how thick is the sheeted dough? Is that the right thickness? Is it even across the belt? If it isn't, then we can make an adjustment to the sheeting rolls or set an alert so that the operator can make that change. Again, in this area of the production where you're, die cutting some product and then knocking the holes out. Okay, are the holes removed? Are the shape of the pieces, are they round or are they distorted? Because sometimes that can be the speeds of the conveyor that are distorting the product, or it can be the speed of the die cut is not moving with the belt appropriately. We can also see if there's any remaining web on the line going through the process, if we need to stop the line to remove that. And again, the most important thing of any vision system, and it's the same as in your QA procedures, is the data you're collecting so that you understand the process very well. So these are the sort of things in real time. You have graphs that are giving you measurements, key measurements. You have the histograms here showing you how variable your process is, and we're looking at different parts of the data. So this is partial is usually for the last 2 minutes. So that's going on. What's going on right now? Total is for the total production run. So you can see here right now they have a problem with, in this case, its height being a little too much right now, but overall the run, it hasn't been as big a problem. and they had some problem at the beginning with the product being too small. So again, I can make a change and then I can see the result very quickly to see, okay, what's happening right now. And then you can see down here in this this biscuit line here, the toppings and things like that. We can see that whether it's properly applied, if it's evenly distributed, all that sort of good stuff. And again, we have, I mentioned earlier about the database to be able to store data and things like that, and then generate reports, allow you to query the database. And we talked about artificial intelligence in the vision process control part of the business. That's the key for us. But what it's also allowing us to do is to see some defects that were always a bit challenging for us to see. So an example would be if you have a defect that is similar in color to the background of the product. So you might have a little brown spot on a donut, and it's not really that dark, but it's something that you don't want to send out to the customer. Sometimes it's a bit of a challenge to see things that are similar in color to the product. Or another situation from my history was we had little stones that were coming in a topping, and they were brown, same color as the bun. It was very challenging for us to see it. AI seems to have a high level of capability to be able to detect these really tough things. For example, clear plastic on a white conveyor. The system can see that and it can reject it. Improved foreign material detection. AI is also being used to help us set up the systems. So you can run good product through, the system can learn what's a good product and set parameters automatically around that, which you can then check, rather than having to start from zero, setting up each individual product. And then also understanding trends and analysis of the data, AI can help you with that as well to get a real picture of what's going on. And AI is very good for shapes. You can set up, multiple shapes that are acceptable. For example, this is a good example here. You have a lot of variation in the fritter that would be acceptable, and then you would have some variations in shape of the fritter that would be unacceptable. And so the system can learn that very quickly. You tell it these are acceptable, these are unacceptable, and straight away it can start to see a product as it's inspecting and say, okay, this one is not within the realm of what's acceptable. So in summary, vision can help you in many ways in the facilities. Number one, it can be automated and objective. So it doesn't matter whether it's Lena or Andrew or Mark, the system's going to see the product the same way all the time, which makes it very consistent. The information is displayed real time and it's very dynamic as it reacts to the process. Obviously, it can save you some labor. I don't need people standing there looking at product, turning them over, looking at the bottom, which is not always a very rewarding position anyway. So we can help eliminate that position. And it's also the ability to really help in the control of the process. Make a change to your process anywhere in the process, and you can see all the things being equal, you can see the result of that at the end of the production. And then vision can also be partnered with other technology to help understand your process much better. And then I'll hand over to Lena now, because she's going to give you another tool that we've worked with them very closely and seen some capability.
Perfect. Excellent. Thank you very much, Andrew. That was really cool. That's very informative. Lena.
Yes. Hi. I am very sorry. We have an additional viewer.
Yes. No, absolutely. That's awesome. Hello.
Would you like a donut?
She's a donut expert, I'm sure.
Yeah. Actually, she is. So no, I'm very sorry about that, but my husband is on vacation.
No apology necessary. No apology necessary.
It's real
whenever
world.
you're ready.
It's real life.
Yeah. It's real life, exactly. Okay. So thank you very much. Can you see my screen? Is that okay?
Yes. Yep.
Perfect. Well, so thank you, Andrew, because it was very informative as well for me. I don't know vision inspection system as well as you do, definitely. Chopin and we are more focused on the flower quality. And here I would just like to share a few ideas of how we can improve quality control, overall quality control, actually, thanks to rheological equipment. Because the fact is that, as Andrew mentioned, we have different kinds of donuts, and the kind of donut that we like in the US or in Canada or in France or in Asia, anywhere in the world, this is not the same. And also we have as many donuts as we have consumers' preferences. And to do that, we have a full viability of processes. And that includes many variables. You have the recipe, then you have the process itself, you have the machines that are used, the external environment, the temperatures, the hygrometry, the timings between the different steps, and of course the human factor, the different teams, the master baker, and so on. And then you have the flour quality, and you have as many flour quality as you have processes and as you have end products. So how do you combine all of that? Well, we believe that flour quality should actually be specific to each baker, taking into account the process specificities and the actual final product that you want to do, that you want to make. And the fact is that in online, in websites, in literature, in many recommendations, consultants might be also sharing this kind of ideas. So here, this is an example on pizza dough. What kind of flour choosing for pizza dough? And basically, it says that if you want to have a good strength, so developed and airy dough, then you should choose a W value of the Alver graph between 300 and 340. Does that ensure me that my pizza will be good? And when we talk about pizza, it's a little bit like donuts. The pizza in Chicago is not the same than the pizza in Napoli. So this kind of advice they do not really integrate the many differences between the baking plants. They do not integrate the variables of each process. And so they do not really correspond to one's reality. What we can do, and the modern quality control system in which we believe is actually, as Andrew said very well, is starting from the end product and starting by collecting data with vision inspection system to have an objective characterization of the process actual performance. And then you can move back on the line, again, with vision inspection system, but also with rheological tools, taking the dough from the line, placing it into the device and define the dough characteristics according to an objective measurement, to an objective data. That is not the feeling of a baker, that is a machine that is not getting tired, that can be easily replaced, and so on. And once you have those data, you can move one step further, one step backwards, and then define the best flour according to the process. It is not complicated. You just have to observe what's going on from the line. If everything goes smoothly, then you have a good flour. And thanks to, again, to rheological tools, you can design specific specifications that has been made for you, and give your millers those specifications that are based on objective measurement of what really works at your plant level, reducing the weight of empirism and experience. And for the millers, that actually also a very good bargain, because that means that they know in what aspect of the flour they need to focus on. And plus, as Andrew mentioned, then we have this entire world of artificial intelligence, which is opening in front of us. And the main food of artificial intelligence is data. Here with this system, you can have objective data at every part of your process, thus building the way to an AI future. But the idea is, if you can measure it, then you can improve it.
Yep.
And so in the end, what we can offer to bakers as KPM Analytics is a complete solution to control the process. To one, have objective measurement of the quality of the final product and the process performance, thanks to vision inspection systems. So as Andrew mentioned, we can measure many different parameters, 2D, 3D, color, toppings, and so on. We can have associated rejection mechanism to really measure the actual performance on the process based on specifications that you designed of what is acceptable or not. And then you can characterize the dough that is coming out of the mixer or at any key point of the fabrication, place it into rheological tools as it is shown in the video here. This is the mixer lab that you can see. And of course, we would be happy to discuss these instruments a little bit more in detail during another presentation. But the idea, yes, is here to have an objective measurement of the consistency of the dough. And then again, analyze flour and build specification based not on common knowledge, but on what has been proven good for you. So I would like to thank you very much for your attention.
Thank you very much, Lena. Very much appreciated. Okay, so yes, this donut view, of course, is a BAKERview is brought to you by KPM Analytics and Vantage Foods, right? So very, very quickly here. There we go. Okay, so we're going to go through a quick introduction, definition of the types of donuts, going to review the ingredients, review processing, and review formulation. And I'm going to do this a little bit quicker so we have lots of time for Q&A. And you can always download the Pocket Guide, which will contain this information and much more. Typically, right now, these days, the donut market is constantly growing, and it has a current value of about $12 billion in the US 2023, and it's expected to grow around annual growth of around 7% until 2031. So that is quite huge, right? Yeast leavened donuts have a bigger market share than their chemically leavened counterparts, and novel current trends are surging due to consumers' interest in healthier baked goods like gluten-free mochi donuts and baked donuts, etc. So donuts are ring-shaped bakery products characterized by their soft and airy texture, which is example most commonly yeast leavened donuts, right? Or their cakey, soft, denser texture, which would be cake donuts. They are made from flour, sugar, fat, as Lena had discussed some of the importance of the ingredients, and a leavening agent, either yeast or a combination of baking soda and leavening acids to make a baking powder. They can be ring-shaped. Sorry about that. They can be ring-shaped, round-shaped, and can be filled with jelly or creams. Donuts can also be topped with chocolate or traditional sugar glaze icing and sprinkles of different colors and flavors. And just very quickly on the name donut in English, is part of where that comes from is because when donuts were first cut on a line, rather than cutting them round, they were being cut with a hexagon cutter to minimize waste. And then they actually look a lot like a nut that goes onto a bolt. And so that's kind of where the North American name donut comes from, right? So there really is no right or wrong. Cake donuts are made from a batter that is chemically leavened using baking powder and baking soda, and they are characterized by their dense cake-like texture and soft crumb. It's easier and faster to produce cake donuts due to their high fat and high sugar content. They also have a longer shelf life. You can typically see these in the grocery store with like 2 weeks or longer shelf life in the grocery store. Yeast leavened donuts are made from a lean yeast raised sweet dough, and they're leavened by yeast. And this type of donut is characterized by its light, airy texture and soft crumb. And they are less sweet, less tender than a cake donut. They have a little bit of a chew to them usually, and they take longer time to make and to produce. We'll get into some of the processing steps shortly. But most people like them because they are so nice and springy and they have a nice bite to them and things like that. And they're also part of this trend with all the colorful decorated like zombie donuts and all this kind of stuff, right? So we have frosted, glazed, powdered. Boston cream are a filled donut that is chocolate glaze and a yeast donut with a pudding filling, a vanilla pudding. And then general filled donuts like jelly donuts or the famous Polish punchki that is eaten on Shrove Tuesday, right? And there are old-fashioned donuts, which is a chemically leavened donut that is fried differently and leavened differently so that it cracks open on the top. And you have bear claws, which are usually filled with either a hazelnut type of filling or almond filling. In the Maritimes here in Atlantic Canada, they are filled with a date filling. And then there's buttermilk or sour cream donuts, which are usually part of the old-fashioned as well. Then you have basically your ring shape. You have bars, which can often be also called stick donuts. They're usually made from a cake donut type batter. And you have long johns. This is again a yeast donut shape. They are long or sometimes also called eclairs. They are not eclairs in the traditional sense made from choux paste, but they're long and they're cut open and filled. Then you have twists and you have balls. We don't have on here is a French cruller, which is made with choux paste. And you have donut holes. So the balls are made from cake donut and the donut holes are made from the yeast donut. They're that little hole that you cut out of the ring. And here we have an image of some of the different shapes, the glazed, the powdered. Beignets are kind of in between the two. They are famous in Louisiana. They are a dough-like product that is chemically leavened. They're like little squares of pasta almost that are then deep fried. There's an example of a Boston cream and a bear claw. And here, this would be in North America, this is called a birthday cake donut with all the different colored sprinkles. Your traditional jam-filled donut, or also called a Berliner, which Kennedy once famously acclaimed he was a donut, right? He said, "Ich bin ein Berliner," which is a Berliner is a jam-filled donut in German. Or it's in North America, it's sometimes called a Bismarck. And then we have apple fritters, where this evolved in donut shops from using the scraps after cutting out the circles. They would chop up the scraps of dough and mix it with chunks of apple or apple pie filling and then deep fry them. And there's an example of an old-fashioned donut as well. So ingredients. So of course we have flour. This can be all-purpose or cake flour, or also unbleached pastry flour, very commonly used. Water, of course, fat, most commonly shortenings, sugar, leaveners such as yeast or baking powder, and egg. Now I will comment, well, I'll get to that as we get through on the different products here too. So in frosting and icing, we also have the ingredients, basically your sugar, but in the glaze, there also contains often shortening, powdered sugar, salt, flavor, color, and then there's usually some sort of stabilizer and gums. And then for decorations, you have nuts and sprinkles. So processing on the yeast donuts. This is the longer processing method that is makes this very popular donut, but it's a little bit less popular sometimes with the baker because it takes so much more time. So you have, we always start off with the ingredient scaling and measuring, metering and measuring. And if you've done your due diligence, you've gone through the QC of your ingredients already with the instrumentation and so on. And then you mix a dough. And from there, we have the first bulk fermentation. This is typically an hour. And then we have makeup. This is when the donuts are formed either into rings, Bismarcks for filling, or twists and so on. One of the methods that is slightly different in the makeup process is what a chain called Krispy Kreme uses, and a lot of larger donut processors who process for retail, they use for yeast donuts what is called a pressure cut system, where the dough is put into a hopper that is then closed and air pressure is applied to it to push the dough through the cutters, so there's minimal yeast, minimal waste that way, and it cuts them very, very fast, right? Then you have your final proofing. This is usually done with yeast donuts. They're proofed directly on the screen that they're going to be fried on. So that way you're lowering the screen into the fat system. It's a little bit different on some of the lines because they're transferred from a screen into a frying well, right? Frying is very quick. Frying can be anywhere for very small, for minis, can be as little as 30 seconds per side. For most average typical donuts, it's going to be between 1 and 1.5 minutes, depending on the characteristics of the formula per side. And in a frying system, there are often then like what they call flight bars that push the donuts through the fat system towards the end where they get flipped and everything. Then we come to glazing, cooling, and icing. So there's really two stages of cooling because you can't glaze the donuts immediately out of the fryer. They do need to cool down slightly, usually to about 110 degrees. Most donuts I see being glazed or finished at around 100 degrees internal temperature. Otherwise, the glaze and the icing that you apply will just simply melt off from the heat and steam coming off of the donut. But then there's the final cooling before you can package them. Because otherwise, if you package them too soon, you're going to trap moisture and you're going to accelerate a mold growth situation and reduce your shelf life. Dusting and coating can be done in different ways. So coating is referring to like adding sprinkles and things like that. Dusting is when they're coated with sugar. Cake donuts, when they're dusted, they go through a tumbler. And so they need to have a certain amount of robustness to survive the tumbler. With yeast donuts, it's usually just the dusting is just sprinkled on top, right? Manually, in a smaller retail type situation, they will be tumbled in a bowl of sugar and powdered sugar. So for cake donuts, you can see right away we have the same thing, measuring ingredients, but then instead of dough mixing, we have blending of the ingredients, adding the liquids, the water. Typically, the ingredients contain, which we'll get to a little bit more about, but there'll be milk powder and powdered eggs in the dry mixes, so that you're just adding water. In the old-fashioned way, not the old-fashioned type of donut, but the traditional method, might use milk and eggs. And so then there's a little bit less blending required in the pre-blending. But then you're just mixing the dough, and you're mixing this enough to thoroughly emulsify it, but also to develop a little bit of gluten so that it holds its structure. Now, the cutting and depositing is different with cake donuts. It goes through a sanitary depositor, which is a system that is a hopper where there's a plunging system that pushes the batter through a cone, a cylinder, and there's then a smaller plunger that comes up, and there's an indentation on the cutter below, and that pulls the batter up and cuts it and forms this ring that drops into the fryer. So it goes very quickly. So if you've ever been to the fair, you've seen these mini donut depositors where they're usually depositing anywhere from 2 to 4 donuts in a row, and the little machine goes ka-tick, 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 and just dropping them in there, and they come out in these little rings, right? So there again, frying is very quick, similar to the yeast donuts, small ones, only seconds. And we're usually measuring this in seconds all the time. And so when I say a minute, we'll be measuring in, seconds, like 55 seconds to 65 seconds, depending on the size of the donut. And once again, a little bit of cooling before glazing, final cooling for icing and other enrobing and so on, right? Like especially if you're glazing with chocolate, it would need to be cooled down below 80 degrees. So formulation on a yeast donut, typically a yeast donut is formulated with a all-purpose type of flour. And most commonly what we see is somewhere between 9.5% and 10.5% protein on a 14% moisture basis of the flour. Yeast can be quite high. So 8.9% baker's percentage, that is referring to fresh yeast. Because this is a fairly high sugar, even within the realm of lean doughs, it is lean in that there's only about 9% fat. But there's like 11%, some as high as 12. I see sugar sometimes, right? Most of the time, what I see is honestly around 8%, right? Because then they like to put the sugar on top, right? And there's usually milk powder. A whole egg is either used in traditional formulas, or in a lot of commercial bakeries, this would be powdered egg, and then just additional water would be added. An improver is used to help with fermentation, to help with dough elasticity or extensibility, or it may also contain enzymes to help with shelf life if this is to be a packaged retail product. Because Yeast donuts typically only have without improver of any kind, they only have a 4 to 6 hour shelf life, and then the staling starts to begin. So if they're going to be packaged retail, you really need to have some enzymes added there to be able to accomplish that. Cake donuts, we can see there's a combination of flour, all-purpose, and cake flour. I actually see a lot more blending of all-purpose pastry and cake flour. Cake flour in North America is chlorinated, so it's very different than what you would see in Europe and many other countries. The protein is denatured and it's very high in water absorption because it's also a smaller particle size. And you can see in the cake donut, the sugar is much higher and the egg is much higher, right? And there is no yeast. Here, baking powder is listed. Most commonly, what you will see is in a managing of the leavening system and using baking soda and 2 to 3 different leavening acids to control that, right? Cake donuts get a short 10 to 15-minute rest time before they are deposited. And that is to allow the baking powder to start reacting so that some gas is produced in the batter so that it expands very quickly in the fryer as well. And you can see the water is only 14% in this example here, right? So talking about icings, Vantage Food provide a variety of options available to you. Gel Plus is concentrated, and it's great for honey buns and other baked and fried applications. The Stable Icing Stabilizer is effective for freeze-thaw type glazes and icings, so make sure that and starting. And so Permafrost is super concentrated stabilizer, specifically for honey bun applications. So honey bun is like almost translucent type of glaze, and this is to help prevent that glaze from cracking, like looking wrinkled, and from weeping, so that you don't get water dripping off of it. And you have an RTU stabilizer that is excellent for formulated specifically for ready-to-use icing. So this is something where the icing isn't cooked or boiled first. It's something where you just combine it together, add the stabilizer, and throw it on. That's usually in more commonly in smaller type of operations, less still commercial, but not large volume. So this was brought to you by Vantage Food and KPM Analytics. But let's get to some of the questions. I see there's lots of them. It started off with DOUGHNUT, and it has in the last, I've noticed it mostly in about the last 25 years or so, that the DONUT is what has sort of usurped it at this time, because, you know, we like acronyms and we like shortening things, right? Because that's only 5 letters instead of the other 3 added to it, right?
I think Dr. Lin was just being provocative. What do you think?
Well, donuts are really interesting. There's a very interesting history around donuts. The Dutch and the Germans both lay claim to having invented the donut, and they argue over it, right? The original name for donuts in the Netherlands is oily balls. And the original name for donuts in Germany is Berlin pancakes.
And I think it depends on what part of the world you're in as well, because I know I come from Australia. In Australia, of course, there is a predominance of DOUGH, you know.
Yep.
But with the with
But that's
Dunkin'
because of
Donuts
the
and
good British English, like we have here in
exactly
Canada as well.
Well, in Australia, it's bad British English, but don't worry about that.
It's actually like that. We write it like that as well in France. DOUGH.
Yep. Mm-hmm. And then people who aren't Anglophones, they get confused as to whether the GH is silent or is it Doffnuts.
I think everyone knows how to pronounce donuts, but no one really knows why it is written
Why?
like
'Cause- yeah.
As long as you know how to eat it, that's the most
Yes.
important.
Yeah. You can never have enough Doffnuts.
That's funny. I can throw in one thing. You know, what we always say to customers is, really focus on what's important to your customers, because at the end, that's going to be your success or failure. And so there's lots, and especially with vision and other things, there's lots of things you can measure, but really I'm only interested in the things that are going to have an impact on your customers' quality perception of your product or satisfaction with the product. So
like
Yeah,
I'm amazed that you can measure the whole, because I've worked with 3D laser instruments that cannot. Their software cannot measure the whole.
really?
It does not understand that it exists.
It's an important thing. It's an
Yes.
important thing. Exactly.
No, I completely agree. When we started to work with quality control, focus on the 80-20, like what is the most important to you, and then move step by step, because it's easy to get overwhelmed with all the possibilities that you can explore.
Excellent.
The answer is yes, but it's obviously we have to be very careful about transfers and also the rejection mechanism, because you don't want shards or crumbs of donut going everywhere if the air nozzle's being used to reject it. So the answer is yes, it can be, but that's kind of what we do, is look at each individual product or the range of products that you're producing on one particular line, because sometimes you're doing, big round donuts, and then you're doing small dough balls, donut holes. So the system needs to be able to cover all those products and gently treat all those products. So the answer is yes. That's a big part of when we're scoping out a project, to say, okay, tell us what you're producing, what you're now and in the future, and let's design the system to handle your product gently, because the last thing we want to do is to any way adversely impact your product.
I think that, as an observation from my perspective, as a working as a baker and as a scientist, is that that's probably one of the big advantages of your type of system, that is you can do that transfer essentially immediately, and so you can that can be the focus at that point in terms of handling the product with respect, so that it does not get damaged or anything like that, and you'll get much better evaluation that way too, right? Because I've been in situations where we've had to make dozens, because just to be able to get 6 of them that didn't fall apart, right, for measuring and things like that, right?
The answer is yes. So at any stage in the production process, you can do an inspection, and sometimes we're inspecting after the cooler but before freezing, and then we can also inspect after freezing, or instead of before the freezer, after the freezer. The one challenge is with frozen product is that sometimes there may be some crystallization on the product as it comes out of the freezer, and so depending on what you're trying to detect, sometimes, if we can't see the surface of the product, we might not be able to see a foreign material in it. But typically, depending how frozen it's getting and what the crystal, if there's any crystals on it, we do a lot of inspection systems after freezing, because often when it comes out of the freezer, it's not totally solid and got crystals all over it. It's solid and it's well cooled down, and it might be quite firm, but then it's going into a carton that's then going to be frozen as well. So if you could see the defects after the freezer, the system will be able to see them. So not too much really, to be honest with you. As I mentioned during the presentation, where we are doing bottom inspection, because dirt falls down, the optical window and the light need to be cleaned at least once a shift. For the upper cameras and the upper lights, not so much, because dirt doesn't go up. And it also depends on your environment. If you have a lot of dust and crumb or flour in the environment, that can sometimes stick to the camera optical windows and the lights. And often what we do is we have compressed air just bursting every periodically to keep the optical window clean. So typical for the upper cameras, we're saying once a week is more than enough. Sometimes it's once a month, but once a week's more than enough. And as far as maintenance go, there aren't too many parts. I mean, there's a conveyor, which of course has to be maintained like a normal conveyor, the bearings greased and things like that. The cameras themselves, they last a long time. The lights last more than 5 years. So again, there's not a lot of maintenance or consumables on the rejection mechanisms, depending on the rejection mechanism. Sometimes we're using flaps and things like that. The flaps maybe once a year would need to be checked for wear and tear. So there is not a lot of maintenance, but there is the cleaning to keep the optical windows clean. It's like Mark, when his glasses get dirty, he has trouble seeing, and that's the same with the optical windows. If that starts to get dirty, you need to clean it. And as I say, if you do that on a regular basis, you don't have any trouble. And then there is also what we call a calibration verification. And all we have is a test disc, which is a similar size to products that you're probably producing. And we would recommend that at least once a week, but some people do it more oftenly. You run those test discs through just to check that it's measuring actually and seeing the images clearly. It's a 5-minute process. Run it through 3 to 5 times. If everything's good, if you get the green lights all coming up, you know you're good and ready to go, and you can have confidence in the measurements. And that's the main reason we do that. It's hardly ever an issue, but if you know that it's measuring this test block correctly, then okay, the measurements I'm going to get after this are going to be accurate.
Well, that again is going to depend on the end result of what you are looking for, what your customers look for. There's a number of different parameters that you want to look at. One of the things is what is referred to as the fry life of the donut. I mean, of the frying fat, and in other words, that it doesn't have a low smoke point so that it doesn't start to oxidize too quickly and things like that. The other thing is flavor, of course. Some people are very particular about the type of flavor, as yeast donuts can pick up more flavor than cake donuts usually do. And then lastly is the amount of solids. If you try to fry a donut in liquid oil, your glaze will not stabilize because that oil remains liquid after the frying. So there has to be a certain amount of solids. And in today's world, of course, since the elimination of trans fat, we have moved primarily to fats such as palm and coconut and blends of fully hydrogenated oils with other oils and so on. So yeah, I would say depending on the type of fry line that you have, the process that you have, and what your end result is you'll want to work with your fat supplier to make sure that you get the one that is right for you. It's a lot like what Lena talked about. It's not just about a set parameters. You know, I could rattle off a bunch of SFI indexes or things like that. It's getting the type of parameters that fit your process and that fit the desire of what your customer expects. You don't want to have a yeast donut that is coated with a waxy film afterwards and you know then and hoping that the sugar glaze is going to cover that up. So you want to make sure that you form enough solids, but not so much that it leaves behind a film, and so that your glaze at the same time will be nice and stable on that donut. For cake donuts, it's pretty straightforward. That's basically processing cake donuts in, I would call it, the proper manner, and also maintaining good hygiene. So it's similar to baked goods. When the donut comes out of the fryer, it's sterile because it has been submerged at 360 degrees for like 2 minutes. There's nothing is going to survive that. It's the environment that it's in afterwards. It's the air handling in your bakery and how the donut is handled. If it's being handled by people without gloves afterwards, etc., etc. So you can add things like propionates, like calcium propionate, or other things, other acids and stuff to lower the pH of it some, so that you make the environment a little less hospitable to mold growth. But by the time we can visually see mold growth, it's usually on the surface, and that means it's a contact point. It's an issue there. Most cake donuts will have 7 to 10 days shelf life, just out of normal processing. Beyond that, you want to look at what is, again, going to be most suitable to your process and your audience. It could be as simple as increasing fat absorption, because the fat will keep it soft and reduce the staling. Or you need to add enzymes to help reduce the staling, right? And when it comes to mold, it's then basically modified atmosphere packaging or freezing and things like that. What a lot of retailers do today is they produce, and as Andrew was mentioning things about frozen, is they freeze them frozen, and at store level, they are taken out and given shelf life.
It's not that difficult. I mean, I think that is a key for us again, is to try and make it very user friendly, so it's very easy for them to use. So our technical team spend a lot of time understanding, okay, for you, what are the attributes that you really want to measure, and then trying to make it easy for you to set up tolerances. But we always recommend that in each facility that you have 1 or 2 key users that get a little bit more training than everybody else. And they can also do some train the trainer sessions, so they can train operators on the line or somebody that's filling in on the line. But somebody who has a little bit more experience, that has a little bit more training, can help you to, adjust tolerances. And also, you also want to have a bit of control over how the tolerances are set. You don't want everybody coming up and making adjustments, because you'll start in LA and end up in New York. And so you want a key user, somebody who said, okay, this is your responsibility. We're going to give you the training, and then you're going to help manage that. And so there is a little bit of training involved, but it's not, any operator that's a little bit clever, they don't have to have a university degree, will be able to use the system and understand what the system's telling it as far as the graphs. A lot of it is graphic to make it very easy.
Yeah, and from the Chopin side, the device I showed is actually very simple. When it comes to dough, you just have to sample the dough from the line, place it into the equipment, and it does the rest automatically. And for the flour, it's pretty much the same. So there is no operator impact on the results. Everyone can use it and will have the same results. So it's completely comparable and completely objective once again. The only thing is when it comes to using the results, you want to have a certain understanding of the curves and of the results that you're observing. And for that, well, we have a specialist here that can assist you. We have a training course online on what is called the KPM Academy. Yeah.
Thank you, Lena. Yeah, I was going to say, you would probably agree that more important is to learn to understand the information, what the results mean. If somebody says to you a W of 300, what is that? What does that really mean? How does that affect my processing? Running the equipment is relatively easy. Right?
Exactly.
Excellent. Well, we've gone over quite a bit. Thank you everyone for your time. Thank you so much, Andrew and Lena, for staying on with us for the Q&A. We still have more questions, and we will try to post those in our our baking industry professionals group on Facebook, and where people can chime in to answer and ask more questions, right? Because the learning continues. That's what we're all about here, and we all want to keep learning. And thank you very much for helping us do that today, Andrew and Lena. And have a wonderful afternoon or evening wherever you may be. And we will see you all in the next one.